I'll give you more overall kind of a presentation of how this workshop is going to go for the 3 days, and then introduce the schedule for the today, and then we'll quickly start some image preparation for the AI. So let me share my screen, and can you guys see everything okay? Yeah, okay. So yeah, this topic of the workshop is the automated facade assembly. So this is a part of my thesis project at the SciArc. My focus was that when I was walking around the downtown LA, there was a very old architecture, new architecture, and then some the monumental architectures, and there are multiple aspects that's within the downtown LA. So I divided into the east and west, and then the see how the old building and the new building correlates to each other based on the image, and then make that as a idea for the facade composition. So to better demonstrate the project, I will share this short introduction video. So this is a west side of the downtown LA. The facade is assembled with the images of the west side of the downtown LA, which is composited with the glass facade and some brick facade and some metal facade. But then each of them are kind of correlating to each other. And then I automated this facade assembly system based on my t-SNE. It is a more like a, let's say, statistical tool to introduce that concept just a little bit better. I'll share this later on. So the overall schedule for the workshop is that if you don't want to, let's say, take your own photos or collect your images, that's fine. I have prepared some images that's my own, and then you can use this as the brochures for the outcome. But then our goal is to collect images around your area. For example, it could be your city, it could be some other urban environment out there that's not necessarily your the part of the city. And then we make the assembly of images based on the image correlation algorithm called the t-SNE. And then based on this t-SNE result, we will try to make the 3D geometries harvest from the images using color feature matching to create this facade assemblies. We will use processing and Houdini to do this job. And then at the end, we will put it in some sort of a rendering software to see the outcome as an all together. And this is the today's schedule. I can share. All this presentation is in the drive. So if you want to check the schedule, you can come back to it. And let me introduce the concept of a t-SNE just a little bit more. t-SNE is a t-distributed. It's a short the word for the t-distributed stochastic neighbor embedding. And it is the nonlinear multidimensional data representation in 2D. There is a 3D information that's floating around, and then what t-SNE does is that it is flattening these 3D information into two-dimensional representation. So as you can see here, there are a bunch of groups of data that has its own let's say characteristics, and then what t-SNE does is to basically vectorize each of data into numerical informations, no matter what it is. It could be words, it could be images, it could be any sort of data. But then the point is that they vectorize the information so that the data that's in the vicinity of that vectorized information is gathered together as a group. This is, let's say, overall kind of a data spread. And then what the t-SNE does is to make them as a group here. This is a, let's say, kind of example of how the data is scattered into the three-dimensional vector space, and each of them is marked with a color. And if you use the t-SNE, this is a kind of a two-dimensional representation. Remember, this is a representation, not actual presentation. And there is something else called the PCA, but then this is just literally flattening the information into 2D from the 3D. But whereas the t-SNE is trying to find the correlationship between the one to another to make, let's say, more of an organic kind of the relationship between one data to another data. So this is more of a mathematical kind of explanation. There is a data floating here, and then they measure the distance from the here to there, here to there, here to there, and then they make this as the let's say distance from the one data to another data. So if, for example, for our case, if we have a facade images from all over the places, then from one facade image to another facade is this. The distance between that is decided by the vectorized information. And this is a example when you use a word. So this is a words from the novel Frankenstein. And when you, let's say, input the whole book as a text, then the t-SNE can sort these the repeated words into vectorized information, so that it can map out how one word relate to another word in that a specific, let's say, the text composition. And this is my result. So I collected a bunch of the facade informations, image informations from the downtown LA. I took a photo myself, and then edited all these images into this small rectangle to have a more of a grid set. Then as you can see, there is a interesting kind of let's say, grouping of a similar style of a facade. Some are more let's say easier to understand for us for human, but then some looks a little bit random, but it's based on the relationship machine's understanding about how one image relate to another image. So it is let's say the interpretation of how machine understands LA downtown as a cultural hub in terms of architecture. And whenever you run this with the different perplexity value, you get different composition, as you can see here. So the this is the process that we're going to do. These are images that I took from the downtown LA. And then we process this image into these smaller swatches. We're not, unfortunately, because of the time limit, we're not going to do this style again, the latent space, the walk. But this is what we're going to do. We're going to make these assemblies of images using t-SNE. And we're going to also use oh no, sorry about that. We are going to also use this use processing to do the feature matching here. How does one, let's say there are 3 to 5 the components in the bank, and then we are trying to match these the components into these image composition. And this is based on the color. If you have this like a color voxels, you can match the your facade assemblies based on these colors too. Yeah, so the final product will be demonstrated as a facade assembly. We're not going to go into the interior, but it's more of a facade study, this part. So your part is that wherever you're located, you contribute to the this image data bank, and then we process this data and then make your own the facade assembly. But if you don't have time, and if you don't if you don't feel like it, you can use my data that's uploaded to the SD platform, the Google Drive. So don't worry. But today we're going to go over how I process the data and then how we can prep these data that is more suitable for the t-SNE application. And just the basics, but then for the AI, you cannot just use a random size images. For machine, it is important to have this sort of a number as a pixel size, because a machine try to understand the images as some sort of a information array. And if your one image is a different size to another image, that is a problem, because a machine treats each one of the information or each one of the image as a one, let's say, data. And if there is a discrepancy between the one data to another data, that's a little bit of a problem, right? And we're going to use processing to segment these the image informations into smaller the smaller images. If you have a big image, why are we doing that? First, we can get more details out of that images, and then once we treat each window, each door, each, like, let's say, decorative aspects of a facade, it will be more interesting to connect them with another set of the facade image. So that's why. But then also at the same time, we cannot collect 500 images, thousand images in one day. So we will use small fragments of your images to make these assemblies. But these dividing the images into multiple images, we are going to use processing. So don't worry. But then there are some manual work that needs to be done in Photoshop. So this is what I was talking about. If you're a human and then taking photos from the street, you always end up with this sort of images. But then our goal is to make this into these nicely cut the architectural elements using Photoshop and the processing. And this is more for the third day. For the third day, we're going to do the image to 3D voxelation using Houdini. You pick an image. It could be your t-SNE image, or it could be your one element of a facade image. Then we analyze the depths through the Houdini based on the image, and we make the various, let's say, height analysis based on this image, and we can voxelate based on that the height. You can use a point cloud. You can use the image itself. Doesn't matter with this script. So this script could be useful for any sort of the image to 3D or a point cloud to 3D voxelization. So this is kind of the process. You have this image, and then using the Houdini, you analyze this the height, and then you do the voxelization. Of course, we'll do the texture map. We can do texture maps and everything in the Houdini, but then I would actually prefer to put it in some sort of rendering software, so that we can texture map and then make it more pretty and nice. So yeah, so this is the how the process works. You put the image and then make that as a height map, and height map to the voxelization. Okay, and based on the image that you have, we can generate normal map and height map to make your image more, and to make the facade assembly more realistic. Okay, and this is the final result. We're aiming for probably not the entire building, but then we want to have some depths in the facade to create more of a, let's say, three-dimensionality to the frontal view. So if you follow along, we can get to this level at the end of the workshop, at least in a smaller scale. as you can see, like I have a lot of articulation based on the factorization, and I have many layers of these like height net analysis, and then make that as a overlaid information to create these multiple depths and more of a kind of machines, how machine sees the image as the three-dimensional component. So that's the end of my presentation for the entire workshop. And if you have any questions, I'll take any question. And this is the plan for today. We're at this point. I'm going to indicate where the image file is for today's purposes of image process. And based on during this time period, we're going to this time is wrong. Sorry about the timeline here, but based on that, we're going to process it in the Photoshop and the processing, and we're going to write a script in the processing to create the datasets. And then at the end of today, we're going to leave with these nicely cut images using the processing in Photoshop. But for tomorrow, we're going to work on the t-SNE work, which is this. If you don't have the nice graphics card, or you don't know how to install the TensorFlow on your computer, that's fine. I'm going to share a Google Colab link tomorrow at the start of the class, so that everyone can run their a script through the Google Colab. Google Colab is a platform where you can borrow their powerful graphics card, so that it's a kind of cloud computing. So you process everything on the online. So to do that, you need to make an account on the Google Colab, and it's free for the slow version. But if you pay like $10 per month, you can get a faster version. For our purposes, I don't think that we need the higher version, but you know, you definitely need the Google Colab account, because that's how I'm going to introduce you guys to the t-SNE. And at the end of today, if anyone's if we have time, I'm going to do more tutorials on the processing to do some cellular automata, so that you kind of understand how processing works in terms of how you make, let's say, the more of a procedural design. It's not going to be in 3D, it's going to be 2D, but then I think for the demonstration purposes of what kind of things that you can do with the Python, I think that could be useful. Okay, so any questions based on my presentation today? Okay, if you don't have any questions, I will go ahead and start with the image processing.